The title is Visual Field in Glaucoma Diagnosis. As you know, diagnosis of glaucoma depends on so many factors. Today, I'm going to rely only on the field. The role of visual field, among other factors, is to establish the diagnosis of glaucoma, staging glaucoma damage, so can help to choose the target IOP, and also monitor progression of glaucoma. But first, we need to be sure that we are dealing with a reliable field. So I need to talk about some of the concepts that you need to correct. This is the first slide I want you to share. This slide showing a field of vision, and my question is, this field of vision shows enlargement of the blind spot, upper nasal scotoma, nasal affection with nasal step. And the possibilities for you to answer is yes, no, or not sure. So I'm going to show you now the voting. Now you are free to start voting. So we have two persons, one quadrant of the people, they say yes. Actually, this is not right. I believe those people who say yes, they depend on the gray scale. The gray scale here shows enlargement of the blind spot, shows upper scotoma, shows nasal step. And we shouldn't depend on this area. We have to go here to the pattern deviation and check. As you can see here, there are changes in the central area. That's all. You don't have even here, this is not real because we have 2 points. There is no nasal step at all. The problem, if you look at the grayscale is computer filmed. Actually, we are testing 70 points, around 70 points, but to make such a drawing, the computer used 2,000 symbols. So we shouldn't depend on the grayscale. Just want to be sure before going further, I want to be sure that you are hearing me nicely. The voting, the poll appears okay. And when I put it off, then I believe we can go on. So I stop showing the results. If this is okay, if everything is going like I said, I need some.
دكتور هو الصوت واضح بس هو بعيد شوية.
اوكي كده يا ترى احسن؟ انا قربت المايك مني.
كده احسن.
اوكي والفوتنج باين ولما انا بظهره بيبان معاكم، مش بيضايقكم في الديسبلاي على الشاشة. اوكي ثانك يو. We can proceed.
لا خالص.
Great.
دكتور انا عندي سؤال في السلايد دي.
ايوه اتفضلي.
دكتور عادل؟
انا سامع، اتفضلي.
دكتور لما اقول enlargement of the blind spot ده معناه ان كل البوينتس اللي حوالين البلايند سبوت لازم تكون كلها واخده بي فاليو، ولا ممكن يبقى في مثلا واحده او 2 مش واخدين بي فاليوز واقول عليها برضه اوصفها ان هي برضه enlargement of the blind spot؟
طيب يعني هو في الحته دي عايزين اقول لك حاجه. السايز واللوكيشن اوف ذا بلايند سبوت فاريبل. حتى مره حد بعت يسالني هم ليه في الايفالويشن النقطه اللي فوق والنقطه اللي تحت في البلايند سبوت ما بيرجعوا لهاش، بيلغوها. فهي الفكره يعني انا عشان اقول enlargement of the blind spot انا هبقى عايز all around points كتير، لكن لو هو في ناحيه منهم مثلا فوق ولا ناحيه منهم تحت هي اللي enlarged، لا ما اقدرش. يعني ممكن يكون ده anatomical variation من شخص لشخص compared to the test field. يعني زي ما انتم عارفين مثلا هنروح في الاو سي تي اما ابتدوا يشوفوا الفوفيا لوكيشن، اما عملوا اكسس ما بين الفوفيا والديسك نورمالي بيبقى الفوفيا تحت الديسك ب 7 degrees، لكن ده في variation among the population ممكن يبقى varied ما بين up to plus 2 يعني فوق الهوريزونتال ب 2 degrees and down the horizontal up to 22 23. So this variation in the tilt or the location will have effect even on the blind spot. The size, the location will vary because we start everything depending on the point of fixation. So keep that in mind. So in answer in your question, we need it all around to be affected to say it's enlargement of the blind spot. Okay, can I go now to the next slide? Okay. This is the patient with 24 degrees, and you can see we have affection in huge area of the field. The question is, in this case, if you are following this patient, should it be to use central 24 as we did here, or should we go to the central 10 degrees, or it's better to use 24 and 10, either on the same setting, or once you use the 24 and the second time you use the 10, once the 10, once the 24. So let me give you the voting. Now you can vote. Okay, I can show you the results now. You have one person who choose to keep following with the 24, and the remaining they choose either 10 or both 10 and 24. Actually, I don't agree with the one who choose 24 all the time. The problem with the 24, let me stop this now. Here, this is the same patient with the 24, and when we repeat the field using the central 10, you can see here we have all these points shown to be within normal. But if you notice here in the 24, the test location between one location and the other is 6 degrees. So here, this is 3 points, 3 degrees. This is 9 degrees. Again, this is 3 from the vertical, and this is 9. So the 10 degrees is here. These 12 points are the limits of the 10 degrees. As you can see here, we have only one point that looks free, and the remaining seems to be affected. While in the central 10 degrees, the distance between one location and the other is 2 degrees. So this is 1, this is 3, this is 5, 7, 9. So as you can see, we have large area to notice if there is progression in the future. So we have to depend on the central. So what about to use both central and periphery? If you depend on the central all the time, you may miss changes in the periphery. So if it's possible to ask the patient to do both on the same sitting, or to do one time central 10, second time central 24, this will be better. And as you notice here in the newer software of the Humphrey, what's called the CETA Faster 24-2C. These are new areas that are included. So it's the 24, but they added extra points here. Why that? They notice that there is macular damage, both structurally in the OCT and functionally in the field, that does not appear, that occur in the glaucoma, but does not appear in the 24 degree. And these changes are common to be seen in the inferior macular area corresponding to superior field changes. That's why when they adapted this part, they chosen these locations being vulnerable to appear early in the glaucoma. So the point, whenever you are having affection in the central area, you have to go and include more tests in this central area by using the 10 degree. This is an example of the CETA-FAST 24-2C, and you can see the location of the points included. And this is the result of the patient. Again, this is the 24. And as you notice here, this is the addition of the affection in the central area. So it is something new. We don't have it, I believe, in Egypt up till now, but we have to keep it in mind. Once it's available, we need to use it. Okay, now I proceed to the next slide. In this slide, I'm going to ask you about these two fields. Maybe I can remove, let's have it, it's okay. The right eye, this side, my question is, the right eye shows pure generalized depression of the field. Nothing appears here in the pattern deviation. And you need to choose one of these three things. So this is the results. We have 1/3 of the response, yes, they agree. And the remaining, they are say, no, they don't agree, or maybe yes, maybe no. Okay. I want you to look here. You notice here, all this area are zeros. And the central part, you get vision, you get decibel, you have a signal here received. But this is not the case shown here. This variation, I'm gonna tell you in a minute how it goes. Now, let's go to the other eye. This eye, the left eye, shows generalized depression and localized changes in the periphery. And I want you to vote now. You agree or you disagree, or maybe generalized depression. This is number 1. Agree there is generalized depression and localized changes. Are you receiving the voting? I don't think. Okay, now you're receiving. So choose 1 if you agree that the generalized depression and localized changes here in the periphery, or you disagree. Okay, this is the result I received. Three-quarters of the people who answer, they say yes. Again, I want you to look on this left eye. As you notice here, there is changes, and the central part, you get sensitivity. So it goes that we have changes in the center and a generalized depression here, and there is changes in the periphery as we notice here. So this is the right eye, left eye. In this situation, it goes with the rule that we always say this is means generalized depression, this is means localized changes, but this one didn't follow. I want to explain why we have this. As you notice here, this is all the sensitivities, and on the total deviation, each location is compared with the normal of that age, and any difference is shown up here. So this is the total deviation. This point is as normal, so it's written here 0. This point is 27, it's written here -3. So it is its normal is 30, that's why it's written here -3, and so on. So each location is compared with that of that age, and any differences are added here, either no change or higher, plus or minus, compared to the norm. Now, what about the total deviation? This is an example of the total deviation. This point is 27. Its normal is 32, so it's written here -5. What about the pattern deviation? We say that the pattern deviation is adjusted. These values are adjusted. Adjusted in such a way, how it is done. To understand it, if this is a group of marks for a group of students in an exam, and we arranged their values, the marks that they got from the highest to the lowest. And a second exam, we got another group of students, and the values were very low, from highest to the lowest compared to the first group. Now, we thought that the problem, not in these students, the problem in the questions we put to the exam. So to overcome this problem, we decided to adjust this value. How to be done? We make the arrangements. We go to the location 85% and compare the difference between the new group and the original that we believe this is the standard. This difference we're going to add. In this example, I'm going to raise all these numbers by, say, 70%. If this value, say, was 100, at this case, I'm going to lower everything by 6%. So this is the root, the rule is decided to be done. Now, we have a patient. This is the normal. This is the values. If we go to the position 22%, as you notice in this example, it is below the average, the normal by 3. Then we're going to raise everything by 3. So all these values will be high up by 3. Another patient, if the value, the 85% is 35 and the normal is 25, then in this case, I'm going to raise everything by 10. This is a program software, just comparing, arranging the data got from the patient, comparing with the normal, and then go to the location 85% and do everything up or everything down. We call this the adjusted values or the pattern deviation. So in our example, in the total deviation, it is shown here -4, -5, while in the pattern deviation, it is shown here -4. So actually the values are elevated by 1. As you see here, this is +1, it became +2. -2, it became -1, and so on. So everything is high up. This is the adjustment that we increase the value and then compare again. Then we get the graphic probability test for that. Now, let's go back to our example. In this situation, these areas with the sensitivity, they are in the upper part of the arrangement. We didn't reach the 85%. But in this example, more points get to the value of 0. So the 85% now is very, very low. It became 0. So the adjustment will be very high. So everything will be elevated so much. So areas that were of no value, they start to be within the normal range. So as you notice here, this area, it is shown to be in the total deviation minus 23. But when the adjustment is done now, it's minus 3. The adjustment is 20. So everything disappears. Just you have few points here to be abnormal, but everything looks to be normal. In this situation, the position 85% is not affected. This is the normal that we are expecting to be all the time, but sometimes we have this abnormal situation when the 85% position is affected. This will give us the false impression. So we have to remove from our minds that every time we see this area means generalized affection, we see this area means localized changes. No, sometimes it can be a mistake and these local areas will appear normal. So we have to interpret the field comparing with the other examination, like the examination of the patient and so on. I hope it is clear. In the recent forms of the printout, whenever the mean deviation reached to minus 20 decibel, they stopped any more printing the pattern deviation to get rid of this mistake. So the point we keep in mind, we don't depend on the grayscale, we depend on the pattern deviation. Again, the central part should not be ignored in the early stages of glaucoma. We need to check it, especially if you have changes in the OCT in the central part. Again, not always this means generalized depression, no local changes. Sometimes this is not true. Now, I'm going to stop for a minute. If anybody would have a question, I'm willing to answer. If you need to unmute you to just tell me, you can write in the chat.
يا دكتور انا عندي سؤال.
أي ست.
هو اوقات المين ديفيشن بيبقى اكتر من ماينس 20 ديسيبل في نفس الجهاز اللي هو الهامفري اللي عندنا، بس ساعات بيبقى مطلع الباترن ديفيشن بلوت وساعات تانية مش بيبقى حاططها، وبيقول ان المين ديفيشن ثريشولد از اكسيدد، واوقات تانية بيبقى حاطط رغم ان الاثنين بيبقى فيهم المين ديفيشن اكتر من ماينس 20. فامتى هو بيعتبر ان هو ما يحطهاش وامتى بيعتبر ان هو يحطها؟
لا مش هقدر ارد على السؤال ده، مش عارف. let me check it. ممكن المره الجايه ما نتقابل اقول لك ايه الحل، لكن انت يعني حاولي تساعديني. مثلا لو 21 هيحطها مره ولا 28 هيحطها، يعني انت راجع كده لحد فين ممكن يحطها وقولي لي، وبعدين انا هفكر او هدور على حل يعني. اوكي. اي حد لو عايز اعمل له unmute just write me في الشات. انا I will check the participants, so I'm going to unmute him. If anybody would like to share. في حد بيتكلم بس صوته واطي قوي.
Yes, دكتور عادل.
ممكن would you raise your voice أكتر، أو لو مش نافع just write your question في الشاتنج.
Okay, so in early glaucoma, it's better to do the 10 degrees also besides the 24?
It's not agreed upon as a routine, but if you have a software that can check the central area more, that will be better. In the Octopus, the point chosen in the central, the locations between one location and the other is 2.8 degrees. This is better. If you are still using the Humphrey, I go for the central 10 if there are changes in the OCT. But up till now, there is no agreement to be part of a routine that we agree to use to go for the central 10 as a routine in every case of early glaucoma. Maybe in the future, this will be part of the management.
Thank you.
Welcome. I got a comment here, maybe from a while, from Dr. Sherry Maurice. There is no voice. I probably could be at your own computer because others, they do not share this complaint. Okay, so I can go on now. Now, the darker the sign, the more the depression. We are accustomed, or some of us are accustomed to say, if you have these marks, this is absolute scotoma. If you have these signs, this is relative scotoma. So you need to choose now. Do you agree or you don't agree? Okay. Now I have 12 persons. I'm going to show you the results. We have 2 persons, they say agree, and the remaining, they don't agree. Actually, I am with the majority. This is not something we need to agree. This does not mean this is absolute glaucoma, and this does not mean this is a relative scotoma. Let me show you. This is the example here. These points are shown here to be with the same probability 0.5. Now, you notice we get this point -8. It is in the range of these points. These points are between -6 to -30. And the -8 on this location get this sign. Again, here you get -6, -7, and the -6 here get this sign, and the -7 at another sign. So the point is, the meaning of these dots, that these points are abnormal, but they can be normal in 5%, can be normal in 2%, can be normal in 1%, can be normal in 0.5%. But this does not mean this is sure is more depressed than the other one. Most probably, the darker should be more depressed, but this depends on the location. The only one fixed rule about the value or the meaning of these dots is the probability being abnormal is 5%, 2%, 1%, 0%. Now, I'm going to show you this field. It's an octopus field. I receive it here in Egypt, and I get this. So, can anybody tell me what is the meaning of plus? What is the meaning of -3.2 in regular font, or the meaning of 4.5 in bold font? Maybe I can make things easier for you. If you know the meaning, you can choose 1. If you don't know the meaning, choose 2. Then I can answer myself if everybody choose 2. If you know the meaning, choose 1. If you don't know the meaning, choose 2. Now I can tell you the answer. In the octopus, first of all, you notice here that they are gathering the results. I'm gonna stop this sharing so you can see better. In the Octopus, instead of choosing results dot by dot, they collect zones, cluster of points. Now, the cluster of points in this, they choose the cluster of points depending on the nerve affection of the nerve, the anatomy, the distribution of the nerves. This is what would appear in the comparison printout. The plus means that this area is within the normal value of 4. Yani if any of these areas is -1, 2, or 3, or 4, they don't write these numbers. No 1, no 2, nothing. You just write the plus. But starting from 5 difference, they start to write the value. This is individual dots. This is the one we are accustomed to receive here now. But the cluster, they start to collect zones and make an average for this zone. And if this average is within normal, they start to get us a plus sign. If this average is below normal, occurs in 1% and 5% of the people, it's written the value here in regular font. If it's 1%, it's written in bold font. So this is the idea. This is bold, so probability, this is abnormal with the probability 1% or less. This is regular with the probability of 5. If it's within normal, then you get a plus. This is the meaning of these signs. So number 1 is normal. Number 2, okay. Number 2 is generalized depression. Number 3 is localized depression. Number 4, you have both generalized and localized depression. So when you look to these numbers, -3 in the mean deviation, 3.3 in the pattern standard deviation. Is it generalized? Is it localized? Is it both? Is it normal? Okay, this is the results. We have 2 persons who will say this is normal. 1 person say it's generalized depression. 1 person say it's localized. 5 persons say it's both. Actually, your choice should depend on knowing what is the limit to say this is normal, this is abnormal. Suppose you don't know the limits. If you know statistics, you can look at this part. As you remember in the OCT, if you have something in red, this means it occurs in 1% of the population. It's abnormal. It occurs in 1% of the population. If it's in yellow, this is 5% of the population. Again, in the pattern deviation and in the total deviation, you can see marks defining 0.5%, 1%, 2%, 5%. And when you see things with the mark 0.5%, 2%, 3, 5, and so on, we say this is abnormal. So simply, if you look here, they are the software is telling you that these values are abnormal. It can be there in 1% of the population, and this can be there in 2% of the population. So this is very rare. This is very rare to be normal. So most probably we have both. This is simply if you have a good statistical background, then your choice should go to number 4. Okay, I'm gonna start now. Just start from the very beginning. Vote now. Depending on these numbers, which one you're going to choose. Doctora Wissal, she raised hand. I'm trying to let her unmute, then she can talk what she wants to say. Doctora Wissal. Okay, this is the results of the voting. I have one person who chose number 2, generalized depression. We all know that if you have abnormality here, this is generalized depression. If you have abnormality here, this is localized depression. So both get a probability of 0.5%. So both are abnormal. So the correct answer, both we have generalized and localized depression. And this is choice number 2 is not correct. Okay, so this is the results. I have 2 persons, they voted that we have generalized depression, and the rest of the votes that we have both generalized and localized depression. Okay, the problem, the term loss variance for many of us does not have a meaning. Variance, if you get the square root of the variance, it will be the standard deviation. So if you simply have this number 67 and you get the square root in any calculator, then you get the standard deviation. So this is high, and we are dealing with both generalized and localized depression. Okay, I get here, I could read the question of Dr. Wissal. The question is, can you tell me the normal values of the mean deviation, pattern standard deviation, and the limits and for interpretation of each? Actually, I don't have these numbers in my mind, but I depend on the sign given to me by the probability next to the number. So if I'm not sure, I just ignore this part and go directly to the pattern deviation, total deviation. So this is my answer. I don't have a limit number to tell you to use. Again, this loss variance, this is again statistics, and it's very easy. If you can know statistics, you can have an answer if you don't have limit number, you know. Okay, now this new slide, these numbers, it's written here MS, MD, SLV. This is the results. Mean deviation is abnormal. I believe some of you didn't have the meaning of these three words. These three letters mean square root loss variance. Square root of the loss variance is the standard deviation. So we have a patient with the mean deviation 21 and with the standard deviation 8, and both these two values, they occur in the normal population in less than 2% or 2.5%. So both these values looks abnormal, and most probably we are dealing with generalized and localized depression. Allow me to stop this presentation and go for a very short time with the statistics, and I want to show you it's not that problem at all. It's easy to understand. Okay. Don't be afraid with the statistics. It's very simple. This is what's meant by mean. If you have some values, if you want to know the average or the mean, I'm going to add these values, divide them by the number of the values, then you get one value. This is the mean. And this is what's shown here in the mean deviation or the mean deviation in the Octopus. They get the differences and they get one value for all these differences, and they write us a number here. Suppose this is the normal group and this is abnormal short group, and we want to know what is the difference between this new short group with the normal wide group. So we see the difference of each person, we get some values, then we make an average of these differences, and we have the mean deviation, the deviation of the second group from the first group. This is the normal halo vision. Suppose points are depressed by 3, 3, 3, 5, 6, and so on. If we get these differences and we get the mean of these differences, we have one value, which is the mean deviation. So this person gets slightly depressed mean deviation, more higher value of a depressed mean deviation, and more. So the mean deviation gives us an impression of the height of the field. If the mean deviation is less than 6, we say we have a mild depression, generalized depression. If it's between 6 and 12, we say we have a moderate depression of the field. If it's higher than the 12, we say it's a high depression of the field, large depression of the field. Now, what about the standard deviation and variance? Suppose we have a group of 5 persons. This is the height of the 5 persons. If you want to have a mean for this group, I'm going to add these numbers, divide them by 5, and we get the mean, 165. Now, we have another group of 5, but the first one is taller and the last one is shorter. Again, if you want to know what is the mean, I'm going to add these heights, divide them by 5, and we get this value as the mean. Another group, the first one is much taller, the last one is much shorter, and if you want to know the mean, I'm going to add these numbers, divide them by 5, and we have the mean. As you notice here, the mean is almost very close to one another. But this group is close to the mean. This group is distributed more away from the mean, and the last group is distributed more and more away from the mean. So the mean is almost the same, but the values varies. Now, to understand this, simply the standard deviation will tell us. Let's see how it is done. Suppose this is the first persons, the height of each one. If we add these and divide by 5, then the mean is 165. The first one is shorter from the mean by -10. The second one is shorter from the mean by -5. The third one, same as the mean. Fourth one is longer, higher, taller by 5. Last one is higher, longer by 10. So this is the difference of the group from the mean. If you are going to add them, the net result will be 0 because there is minus signs and plus signs and the mean is always in the middle. So they will cancel each other and the net result is 0. So to get rid of this, they want to get rid of the minus sign. So simply, if they square everything, multiplied by itself. So this one, when it's multiplied, it will be 100. This one, when it's multiplied, it will be plus 25. 0, same. Plus 5 multiplied by 5, it will be 25. Plus 10 multiplied by 10, it will be 100. Now, if you add them, you have a value. This value, if you again divide them by the total number, this what's meant by the variance. So the variance is simply something was done to get rid of the minus sign. The second step, as we start to multiply the number by itself, if we get the square root of this value, this is the standard deviation. So differences as it is, the whole group get a difference of a 0 because some are minus, some are plus. If you multiply it by itself and divide by the number, this is known as the variance. The larger this variance, the more the group is distributed away from the mean. Now, because we multiply the number by itself, if we get the square root, again, this is the standard deviation. In the Octopus, it is termed loss variance. And in the new software of the Octopus, it's written SLV, square root loss variance. And in the Humphrey, it is written pattern standard deviation. So simply, this is not something very hard to understand, but you have to keep in mind these steps. They want to get rid of the minus sign, so they multiply the number by itself. They add, divide by the total number. This is the variance. If you get the square root of this process, this is the standard deviation. As you notice here, when we calculate that, in the first group, the standard deviation 7. In the second group, the standard deviation is 11. In the last group, the standard deviation is 25. When the variance or the standard deviation is high, this means one of the values is away from the rest of the group. And this is what happens with the field. If you notice here, when one of the values is away from the rest, the standard deviation will be high. Then we know we are dealing with localized changes in one area. Okay, I hope that is clear. If further. Now, to establish a diagnosis, I'm showing you this field, and the question I want to ask you, can this be glaucoma? You can say no, or you can say yes. You can say yes because you see one point, one area, or one parameter, or you can say yes, 2 plus, that you have 2 variables seen, or yes, 3 plus, because you can see 3 variables. So now you can choose 1, that there is no glaucoma, 2, yes, 3 yes, 4 yes, but depending on how many values or parameters you see in the printout that will support your point of view. Okay, so yes, everybody agrees that there is glaucoma, and you can see the percentage. Most of the people answer with 2+. This is the old parameters that used up till now in the clinical studies for the diagnosis of glaucoma. The glaucoma hemifield test outside normal limits, that is standard deviation higher than 5%. And this is the main part. Cluster of 3 or more points abnormal in the pattern deviation, located in area that we know it is that of glaucoma. Glaucoma affects such an area, and it respects the horizontal line. This is the main point, clusters of points, and the value of this cluster of points, its probability is high to be normal in a normal population, so the standard deviation is high. And here they are comparing the upper half with the lower half, and again this will add. So this is the main point. So glaucoma hemifield test outside normal limits, better standard deviation, and changes here. This is the blind spot, and this is output extending more, getting toward the altitudinal. You have here nasal stap and so on. So we are more and more sure that this is glaucoma. Diagnosis of glaucoma, we keep in mind check for asymmetry, whether in the OCT or in the field. And this is the idea of the glaucoma hemifield test. They divide the field up and down into zones and compare corresponding zones. If one of these zones, the difference between the upper and down, occurs in less than 1% of the population, you get this outside normal limit. So any of these 5 zones compared up and down, if one of them is outside, if occurs in less than 1% of the population, you have this print out, outside normal limit. If this difference is between 1 to 3% in this zone, it's called borderline field. Then we have to check areas of glaucoma field changes. And then it's better to look for clusters of points. In the early stages, we say we need to have 3 points touching one another. In the new softwares, like in the Octopus, they located the points according to the distribution of the nerve, and then they start to collect areas known to be affected together in case of glaucoma, and we have this ready for us. Now, for the staging of the glaucoma, if you see such a field, would you consider this, if this is a glaucoma, would you consider this a mild or a moderate or a severe? So this is the result. I have 3 persons, they choose to be severe. Most probably, if you want to diagnose severe glaucoma, we'll say there is affection in the central area or the mean deviation is higher than 12. So most probably they depend on that. But I want you to look here, this area with the mark, or this area, you get sensitivity 28, 28, 25. So if I depend on that, absolutely, no, this is not the case. In the older systems, they will say severe glaucoma means that you have a value of 0 in one of the upper or lower part, the central upper or central part, and they say moderate if you have a value less than 15 decibel. So actually, the values here didn't reach a decibel 15. 15 decibel up or down, this is moderate. 15 decibel both up and down, this is severe. 0, this is severe. This is the old system back into 1993. So actually, I don't agree with the third choice. This is mild glaucoma. I don't know why people choose moderate, because I just depend on that. I will ignore that. Or maybe some people will go and choose there is multiple affections of one of the two hemispheres according to the American guideline. Then we'll go, this is mild glaucoma. This rationale for such a difference in the decision. So simply, yes, it can be mild if you want. If you go for the Canadian, it can be mild. If you go for the American, it can be moderate, but it is not severe.
يا دكتور ممكن اسال سؤال؟
طبعا.
هو انا اخترت مودريت، بس انا اخترتها على اساس ان انا عديت النمبر بتاع البوينتس اللي هم البي فاليو بتاعتهم less than 5% in comparison لكل التوتال نمبر اوف بوينتس 54، فطلعت الريشيو 33. فهو الكرايتيريا كانت فيها ان هي من 25 to 50% بنعتبرها ان هي مودريت، اقل من 25 مايلد، اكتر من 50 سيفير. فدي بنحطها في الاعتبار برضه ولا يعني
عايز اقول لك هو اللي انت ماشيه عليه ده من سنه 1993، يعني كتر خيرك على صبرك وانت جوينج لايك ذات لحد دلوقتي. لكن هو الاسهل ان احنا نبتدي نقول طب احنا هنمشي امريكان او كنديان. ما اقدرش اقول لك ان في واحده من الثلاثه ديفينتلي هي دي الصح. اتس اب تو يو. لكن انا مثلا عندي لو هاخد امريكان ولا كنديان، للامريكان هعتبر ان الامور هي ماشيه يعني بسيطه، ولا الكنديان هعتبر ان الكنديان ابسط والامريكان اعلى. ما فيش ليميت، ما حدش هقول ده صح ولا ده غلط. فاكشولي اتس اب تو يو. ما حدش يقدر يقول لك امشي على كذا او ده صح عن كذا. لكن انا في الاخر انا عندي فاكتورز كتير من ضمنها الفيلد عشان اقول العيان ده الدمج فيه قد ايه عشان اختار تارجت اي او بي. وعندي فاكتورز ثانيه، يا ترى العيان ده مثلا ريسكي هي دي عينه الوحيده، في اذر ريسك فاكتورز في الهيستوري بتاعه، في الاكزامينيشن بتاعه، ممكن تخليني اغير اختياري. لكن ما اقدرش اقول ان انت اختيارك كان غلط. لا، اختيارك صح، بس ما حدش بيستعمله كتير دلوقتي. يعني الناس لما عملت الجايد لاينز نقوا الاسهل كده. ما اعرفش اليوروبيان جايد لاينز لسه بتكتب اللي انت قلتيه ده ولا لا. انا مش عارف، انت عارفه احسن مني.
لا بتهيألي لا، دي القديمة فعلا.
اوكي بس you are right، يعني nobody can blame you for that. This is the way the American guidelines will say glaucoma is mild with no field changes at all. Glaucoma is moderate with affection in one of the two hemispheres. Glaucoma is severe if there is affection in the two hemispheres or in the central part. The Canadian guidelines will say changes, this is early, significant changes but not in the center, this is moderate, affection in the center, this is severe. So there is no hard borders between different systems. Okay, I think this will be, I want to go a little bit quicker because now it's 1.5 hours. So mostly you'll get bored. Now I'd like you to go for this one. This slide or this field is tricky. Most of the people choose to be moderate, but if you look a little bit up, this is the central 10 degrees. It's not 24. That's why you get this trick, fall in this trick. So all these changes are in the central area. Okay. If you are accustomed to look at the field, these marks, whenever you see it, you think, yeah, this is central 10, check here, this is 10, check here, this is 10. Okay. Now, this one, this patient has a localized changes only, and there is no generalized changes. Okay, so we have 3 persons agree, but we have 5 they disagree, and also we have Dr. Heba who wrote to me that no way to get localized changes without generalized changes. I'm repeating this for one reason. Let's remember that position 85%. Numbers here are very high. This field was done for a child, 11 years old. He was a happy trigger. He got everything. He sees everything very well. As you can see, the sensitivity of the numbers here, 63, 59, and so on. If you have these numbers arranged from the highest to the lowest, the position 85% is very high. When it compared with the normal, then everything will be dropped. So everything is dropped here to be minus so and minus so. That's why you get all these values. These marks being abnormal only in 0.5% of the people. So I'm just putting this again to keep you in mind. Sometimes this does not mean generalized, this does not mean localized. Sometimes this is not the case because the system allows such a change to be abnormally printed for us. So this is unreliable field in a happy triggered child with a very high sensitivity. Okay. Now, the field for monitoring progression. This is the patient with the follow-up. As you can see here, this is the pattern deviation or the repetition. It's okay. Again, we get some changes, no changes, some changes. So such a field, is it progressive? Is it stable? What do you think? So we have one person say it is progressive. I want to tell him no way to say changes are real unless they get the same changes at least in 2 subsequent fields. So if you consider this is progressive compared to what we have before, you need to repeat second, third time, and you get the same changes. So most probably it is stable, it may be progressive, maybe not, nobody can tell. Why I'm putting this? I'm putting this because we should stop putting fields next to each other to say, yes, this is progression, to say, yes, this is progression. This is not a correct way to do. We may fall into wrong decisions. Actually, progression is diagnosed by changes in area or global factor changes over the time. This is a very important paper. I want to show it to you in details, and this will change your mind. Back in 1989, this group, Hegel, they get 51 persons with different grades of glaucoma. They test them 4 times within 4 weeks period. So this is within 4 weeks, no way for the glaucoma to progress. And they check the field 4 times for each of them over the 4 weeks and to see what the variation will be. They found that locations with the sensitivity near normal, the fluctuation is somewhere between +3 to -7. Locations that are depressed by -6 than the normal, the variation, the fluctuation is between +1 to -16. While areas depressed by -8 to -18, the fluctuation can be anything from the whole range up to 0. So whenever the sensitivity of the point is near normal, the fluctuation is limited. When the area is or the point is depressed more and more, the fluctuation is higher and higher. This is the first point. Second, they found that changes in the central area is limited, the fluctuation, while the periphery, the fluctuation is higher. Third point, they found that depressed points in a generally depressed field, a field, the mean deviation as a whole is depressed. These points show more retest fluctuation than similarly depressed points in an otherwise normal field. Meaning that if you have two fields, one of them is the mean deviation, the general field is depressed, say -10. And another field with mild depression, say -1, this is the general depression. Two locations, same location, one of them is -7, second one is -7 depressed. In case of generalized depression, the fluctuation is high. In the high depression field, the -20 mean deviation, compared to the same -7 location in another field with the slight generalized depression. So they reach to these three things. The fluctuation varies with the sensitivity of the test location. It varies with the location itself being central or peripheral. It varies with the general state of the field, the mean deviation of the whole field. And accordingly, the Humphrey make maps to decide which location, what is the limit to say this is fluctuation, normal fluctuation from interfluctuation tests from one time to the second time, or this is abnormal. So over the time, the first two tests, the location, one location, the first two tests is average. And then on frequent testing, the same location is compared with the average. If it's below that level, then it's fine. And every time it's okay. Then once this location gets worse than the level they decide, then they show you triangle, white triangle. If this is repeated for a second time being abnormal, they show you a triangle half white, half black. If it's 3 times, they show you a triangle totally black. What is that level? That level depends on the sensitivity of the location itself being central or peripheral, the mean deviation of the whole field. These values you cannot see with your eyes. This is something you have to depend on the machine. And this is what you're going to receive. These marks. This X means that this location is so depressed that we are not sure about its fluctuation. So these points are not evaluated. When the whole field is depressed than 20 decibels, this printout is not shown anymore because cannot be sure what's going on. So the glaucoma progression analysis, it depends on the pattern deviation probability map. Now there is 3 or more test locations, not necessarily touching one another. If they show significant deterioration in 2 fields, then you get the term possible progression. If it's in 3 consecutive fields, then it's termed likely progression. And this is what is shown, and this is what's written here, okay? So we need to depend on that. Again, this is area, and you can see here, change these points, sensitivity is very low, then it's not tested anymore. This is the shape of the printout. In the exam, the last exam, almost many people couldn't figure out what's going on here. Some will say, yes, this is one field, this is another, this is right, this is left. Some people will say, oh, this is one field, this is one. Actually, these are the 2 first baseline fields that are average. They are shown here just to be sure that they are reliable, dependable. The operator can change them. And this is the current field. And again, in between, there may be some other fields. You can go over the machine and ask for any of the in-between ones, compare them with the baseline. So this is comparing dot to dot. And in this area, you got the trend analysis or the glaucoma progression line. So event analysis depend on checking points, and you can get changes shown and after 4 fields or 5 fields, while the trend analysis, the visual field index, needs higher number of fields. The trend analysis can be done over time using the mean deviation or using the field progression analysis. Now, question. Do you know what is the difference between the mean deviation and the visual field index? So almost half will say yes, half will say no. I'm going to mention it quickly. The visual field index, it's a way to get rid of the effect of cataract because it depends on its calculation on the pattern deviation. In the values of the central parts, the central 4 points are multiplied by 3. The next string is multiplied by 1.2. The next string is multiplied by 0.8. The most peripheral is multiplied by almost 0.5%. So actually, you are increasing the value of the central and decreasing the value of the periphery. Why is that? Because the central part is presented in the brain in a large area. It was found that if you have change in the field in the central area here, you need to damage 230 ganglions. But if you go peripheral, the same defect can appear if you damage only 35. If you go more peripheral, the same defect will appear if you have in the field, if you have 10 ganglions. So whenever you have defect in the field here, this means high affection of numbers of ganglion cells. So the visual field adds to the strength of this area and minimize the effect of that area. So this is more sensitive than using the mean deviation as a whole. There is a whole presentation on my site, how it is calculated and how to go through. Again, in the follow-up in the Octopus, they can give us trend analysis for the mean deviation, the standard deviation, the diffused affection or localized affection. This 1/4 is known as the diffuse affection of the field, and this 2/3 is 3/4 here is the localized defect, and the gap is analyzed over the time. Okay. Now, I guess this could be my last one for the polling. In this field, this patient has a generalized depression and localized depression in the central area. Agree? Disagree? Maybe. Okay, so we have 63% agree and the remaining maybe or disagree. So again, those who agree that the central part that you have here, sorry, I want to close this. Okay, so as you can see here, still those who believe this is generalized, this is localized. If you see the numbers here, everything is zero except 2 or 3 numbers in the central area. This means that the location 85% is now markedly depressed, so that when the adjustment is done, everything is improved. So here you get minus 35, but it became only minus 3. It improved by 23. This is minus 30 something. This is minus 5 only. That's why everything looks perfect here. As you notice, this is the third time I'm repeating the same question and I'm giving the same answer, and still some are not catching this. What's my point of view? That in order to have this as a part of the learning process, you have to be trained for that over and over and over again. So this was the idea of having something interactive like this. And in the past few days, I learned something new, and this new something will help me to prepare the material and to be available online without being restricted to specific time, because maybe time will not be suitable for everybody. In the past few days, I managed to prepare a Google quiz or Google form with this same presentation, with the questions, and ask people to answer. And I get their feedback. So next, I'm going to go back to the same, add more or remove some. Then I'm going to add the answer. The answer can be written or the answer can be a video. So instead of having 2 hours to spend together, I'm going to repeat the same thing on a digital form. Just I'm going to supply the link. Supply the link will be very simple. I'm going to go to my YouTube channel, make a small video that this is an interactive material for the field. And in the description below, I'm going to have the link. Then later, I'm going to have another interactive for the OCT or for the gonioscopy or for the choice of target IOP and so on. And all this will be available for people to go and answer. And once they finish the questions, they get a feedback. In the form I already made, they get to fulfill 18 questions, then they have the marks, but I'm going to cancel this. So anybody can go for 1 or 2 or 3 questions, it's up to him, and make the choice, what's his choice, and immediately I'm going to receive the answer, yes or no, for what reason. And this way, I think this will be a simple interactive, and it will not depend on your free time, but it will be available for everybody to share whenever he wants. So I think this is the only interactive session I'm going to have. Now we spend 2 hours. It's a hell of time to spend listening to one person talking. I know the maximum people can listen is just a couple of minutes. So just keep an eye on my YouTube channel. And also, if you have any suggestions or some material to add or something to change in the way we are discussing things, just write in the comment below the video. For me, my website, I'm not intended to keep it anymore. It was for auto renewal. Today I canceled the auto renewal, so it will be there available till next April. then it will be out. Actually, I don't need it anymore because now I found I can do the same simply using the YouTube and the Google Forms without paying money for the having a website of my own. So I want to thank you of your attending. This is something great. I know not easy for people to join, especially on Friday. And I hope you can follow me whenever I put something in YouTube channel. And if you have some difficulty in some parts, just simply let me know. And I will, if I can do it, I will do it to cover whatever you want. Thank you for your attendance. Thank you very much and have a good night.